let's take a look at matrices and matrix operations. If you look down here in example 1, you're going to see this matrix. Okay. Now, as you'll see, matrices consists of rows and columns. Okay. We describe a matrix by its number of rows and number of columns, and we can label each entry in the matrix and identify its location by its row and column that it's in. Okay. When we describe the dimensions of a matrix, we typically say it is a 5 by 1 or a 6 by 2 or a 3 by 3. It is rows first and columns second. So the matrix that we have here on the right, this matrix A, its dimension is 3 rows by 3 columns. So it's a 3 by 3. Okay. So rows first. Next, when we're talking about the entries in a matrix, if I say what is entry A sub 3, 1, that 3 and that 1 is giving us the same information. What is in row 3, column 1? Well, A sub 3, 1 is a 3. Okay. The next one is what is in second row, second column. So row 2, column 2, and that is 4. Okay, so we can describe each entry with its location, and we can talk about the dimensions of a matrix, and it's always got to be rows then columns. Okay, let's talk about matrix operations with matrices. So we can add, we can subtract, we can multiply, but there's tricks with the multiply, not so much tricks, but rules with the multiplication. We're going to start with adding and subtracting. Because the dimensions play a role in the operations that we do, and when you're adding or subtracting matrices, you have to do it compartment-wise. So you have to have, for every entry in the first matrix, you have to have an entry in the second matrix. So in other words, they have to be the same size or you can't add and subtract them. Okay, so right here, this example 2, if I'm trying to do matrix A plus matrix B, they have to be the same size because each entry gets paired up. So row 1, column 1, row 1, column 1. In the matrix, we will have A plus E in that spot. Okay. Row 2, column 1, row 2, column 1. Row 1, column 2, row 1, column 2. And lastly, the same. So if you have a 2 by 2 matrix, and you have to have a 2 by 2 matrix that you're adding it to, because it's all compartment-wise. So if we run down here to this one with numbers in it, the sum of the A plus the B matrix is going to be 4 plus 5 in that spot, 3 plus 0, 1 plus 9, 2 plus 7. In other words, matrix A plus matrix B is 9, 3, 10, 9, just like so. All right. The difference, well, it's very similar to adding, except which one are you subtracting, right? Well, the difference of A and B is A minus B, right? So whatever comes first minus whatever comes second. So it's, again, compartmentalized. So it'll be negative 2 minus 8, 0 minus 5. Row 1, column 2, 3 minus 1, 1 minus 4. So in the end, we will get negative 10, negative 5, 2, negative 3. And they were both 2 by 2 matrix, and adding or subtracting will then result in a 2 by 2. If you had a 3 by 4, you would have to have a 3 by 4 to add or subtract with it, and the answer would be a 3 by 4. Okay? All right. So Here it's saying find the sum and find the difference, so it's just another one to practice. Same idea with, so let's do the sum first. A plus B, and I'll maybe do this one a little bit quicker. 2 and 6, -10 and 10, -2 and -2, 14 and 0, 12 and -12, 10 and -4, 4 and -5, and make sure I go slow enough so I'm not making errors, right? -2 and 2, and I'm adding 2 and -2, and I'm adding. So there's the sum. Difference, A minus B, (2 minus 6), -10 minus 10, -2 minus a -2, turns it to adding, 14 minus 0, 12 minus a -12, 10 minus a -4, 4 minus a -5, -2 minus 2, 2 minus a -2. Whew, there we have it. All right. Anytime you're watching videos, pause, do the problem, see if we match in the end. And also, I'm human too and make mistakes. So sometimes I make a video, make a mistake and don't catch it. Please let me know if I do, though. All right, scalar multiplication. Scalar multiplication, anytime the word scalar is used, basically they're just talking about a real number that's getting multiplied by something. So here, if I take an entire matrix and I want to multiply it by a scalar, which is just a real number, for matrices, you just multiply every single entry by that number, okay? So like here, they're using C for the scalar. Every single entry, here it's laid out front, and then here every single entry gets multiplied by that scalar. So if we come down here, if they're asking us to find 3A, basically you take your entire matrix A and everything gets multiplied by 3. There's 3A. And I know we're going to add that to 2B, but let's find 2B first. Matrix 2B. I should have nice handwriting. Is going to be, I'm just running through this and multiplying everything by that scalar. Just like that. Now, this particular example is saying, hey, you need to find the sum of these two. So what is 3A plus 2B? Well, we're going to add these two together. Compartment-wise, excuse me. So this 3 has to get added with the -2. This -6 and the 4, 0 and the 2, so on and so forth. So we will have 1, -2, 2, 0, like so.